Good evening. I welcome you all for today's session, flash type and successive approximation type in ADC. So far we have discussed what is ADC and what is DAC, and in ADC we are going to discuss about flash type ADC. So here you can see the circuit diagram for the flash type. We can see number of resistances and comparators and 8 to 3 line priority encoder and some outputs, right? So as the ADC we are giving analog input and we are receiving digital output. So how can we calculate these comparators? So to calculate, in order to calculate this number of counters to fix, if we want to design a 3-bit ADC, we have to follow the formula 2 power n minus 1. So if we want to design a 3-bit flash type ADC 2 power 3 minus 1, so we need to fix 7 comparators in this circuit. Now this circuit is 3-bit flash type ADC. We have connected 7 comparators and 7 voltage divider resistances and 2 inputs. One is voltage inputs, one is VA and another one is VD. VA is analog input and VD is reference input voltage. We are giving 2 input voltages, and this comparator, both inverting and non-inverting inputs, are connected with both the input voltages, analog input voltage and reference input voltages. If our VA input voltage is greater than our reference voltage, then our comparator output will be 1. If our analog input voltage is lesser than our reference voltage, then our analog output, comparator output will be 0. So this is the principle of this flash type ADC. That is, 2 input voltages will be compared in this comparator and will be forwarded, and the output will be received by 8 into 3 line priority encoder. There the data will be encoded and we will receive the digital form, binary form output Y0, Y1, Y2. So this is the function of flash type ADC. We are giving the input, analog input, and receiving the digital output. So this is the function of flash type ADC. And the next one is successive approximation type ADC. Successive approximation is one of the most widely used methods of digitizing an analog signal. See, we can see this is the circuit diagram of successive approximation register. Once if register is available in any circuit, then we need clock pulses. The only difference between the previous flash type and the successive is we are using clock pulses here. So only one comparator which consists of 2 inputs, VA and VD. Then we have a successive approximation register which have one input and output, that is SOC and EOC. SOC is start of conversion and EOC is end of conversion. Then we have a DAC output. We have a clock pulse. Here the function is we have to fix one correct digital representation, that is VA. And for each bit, if it is an 8-bit, each bit we have to access and convert from analog to digital. So first we have to access the first bit, and we need to put all the remaining bits as 0. So we need to compare whether the VA is greater than VD. If VA is greater than VD, then the output will be 1. This is same like our flash type only. If our VA is greater than VD, then our output will be 1. Next one, see, 1, the second bit is to be accessed. Second bit is 1 and all the remaining bits are 0. So here also our VA is greater than VD, so our output is, comparator output is 1. The next one, third bit, if there is any error, if our VA is lesser than VD, then our output will be 0. So when you get your output, comparator output as 0, then in the next level you have to put 0 for that particular bit. So as we get 0 in the previous bit, we are receiving an error. Here we are putting 0 in the third bit as 110110000. Likewise, we have to convert each bit with this correct digital representation one by one and the remaining bits as 0. Once all the bits are converted, then our output which we have given as the correct digital representation will be received in our